Question 7, paper 2, September 2014. I'm not going to do the proof of the theorem, the cos rule in 7.1. Let's go to 7.2. In the figure, the diameter PQ of the circle is reduced to R. So we know that PQ is a diameter. And that's very important to note in the beginning, because that means that we have a circumference angle on that diameter that will be 90 degrees. So that's very important. And S is a point on the circumference such that QR equals QS equals X. So let's indicate that QR equals QS equals X. P and S are joined and QPS equals alpha. Right? So immediately before we even do something, we can work out that Q2 is going to be, now that must be 90 minus alpha, and we can also work out that Q1, while being the exterior angle of this triangle, will be 90 plus alpha. Right, so now let's say prove that SR equals that expression. So we are going to start by saying, because we need to indicate it, we need to say that we know that PSQ equals 90, and the reason for that is the fact that PQ was a diameter. PQ, diameter, and circumference angle. Then we also worked out that Q2 equals 90 minus alpha. 90 minus alpha, the reason for that is sum angles of a triangle. Then Q1 equals 90 plus alpha. You can either work with straight line or exterior angle of triangle. And from that we can say that in triangle QSR, we know the following. Now, triangle QSR will be this triangle, because we need to get to SR, and SR is in that last triangle. So SR squared, and I'm going to apply my cos rule, is SQ squared plus QR squared minus 2 times SQ times QR cos of the angle between SQ and QR. SQ and QR. So that angle there. Always remember for the cos rule that you need to have two sides and the angle between them. So it is the angle SQR. And now I'm going to fill in my values. SQ was given as X. QR was given as X minus 2 times X times X times the cos of 90 plus alpha, because that was the angle that we determined. Then simplify all of this. It is 2x squared minus 2x squared cos of 90 plus alpha is the same as minus sine of alpha, because cos of 90 plus, that brings us to the second quadrant, and cos is negative in the second quadrant, so it must be minus sine alpha. That can be simplified to 2x squared, and minus times a minus is a plus, 2x squared sine alpha, and take x out as a common factor of x squared. It's 2. You can actually take out 2x. Now, if we look at the result that they want, we can just leave the 2 inside. So it is going to be 2 plus 2 sine alpha, and therefore SR is equal to, and they want the x outside, so it's the square root of that, square root of that. It will be x root, and now 2 can come out as a common factor inside. Let's just write it like this. 2 sine alpha. But they want the 2 to be out, so it is x 2 out as a common factor, 1 plus sine alpha. And that is 7.2.1. Sorry, my number was wrong in the beginning. Then 7.2.2, if SR is now given as 5 root 3 and x equals 5, show that PQ equals 10. Okay, we know that, so it is 7.2.2. SR is 5 root 3, and that is still equal to 1 plus sine alpha. X is given as 5, so it is 5 root 3 equal to 5 square root 1 plus sine alpha. That 5 and 5 can cancel out. Divide right through with 5. Therefore, root 3 is equal to root 2 bracket 1 plus sine x. If I now square both sides, which is 3 squared, which will be 9, and then remove that, so it is 2 1 plus sine alpha. Sorry, not 3 squared, it's root 3 squared, which is just 3. And then divide this side with the 2, 3 over 2, 1 plus sine alpha. And then 3 over 2 minus 1 is just a half, equal to sine alpha. Okay, if sine of an angle equals a half, then the angle is 30 from your special triangles. So alpha equals 30. So now we can say that in triangle PSQ, we can say about the sine of alpha, and this is a 90 degrees, the sine of alpha will be, okay, so let's first write that. Therefore, in triangle PSQ, we know that QS over PQ equals the sine of alpha. So PQ equals QS over sine alpha. Well, QS is 5, and the sine of alpha is just the sine of 30, because we proved already that it is 30, and that is equal to 10 units. Thank you.